Lesson 4-5, matrices for scale changes. The big idea is matrices can represent scale changes. Now, as you remember before, we talked about size changes. Okay? Size changes were coordinate points that were multiplied by the same number. Okay? Our letter K, it was. 0 everywhere else. A size change is actually a type of scale change. But what can happen in a scale change is you can stretch it by different numbers, okay? And in a scale change, and what you're going to see here in a little bit, but you can change your x values by some number, and then you can change your y values by some number, okay? And we're going to show you how to do that in just a little bit, okay? So let's move on. What is a scale change? In the previous lesson, you studied size changes, which are transformations in which the changes to the preimage have the same magnitude in both the horizontal and vertical directions, as shown before. We moved it vertically and horizontally by the size k, okay? Sometimes it is more useful to apply a transformation in which the horizontal and vertical changes have different magnitudes, so it stretches further than the other one. For example, imagine a friend hands you a rubber band and says there is a secret message written on it. The writing on the rubber band looks like the picture at the left below. If you apply a size change and stretch the rubber band by the same amount in both directions, it looks like the picture in the center. It is still unreadable, okay? However, if you stretch the rubber band more in the horizontal direction than the vertical direction, it looks like the picture at the right, and you're allowed to read the message. Pretty neat. Everybody loves advanced algebra. Transformations that multiply coordinates by constants are called scale changes. Transformations that multiply coordinates by constants are called scale changes. You're going to want to write that down. Okay. The definition of a scale change. For any non-zero numbers a and b, the transformation that maps xy onto a times x, comma b times y is called the scale change with horizontal magnitude a and vertical magnitude b, and is denoted by s of a, comma b. Okay, if you remember our size change before, if we had a size change, remember s sub 4, that means 4 went here and here. This was 0 and 0. So in our scale change, where maybe we have something like 3 comma 5, then 3 is going to go here, 5 is going to go here, and 0's everywhere else. Okay? So when doing this, all you have to do is take your x times your a value, get your x coordinate, take b times your y value, get your y coordinate. Okay? It says when the absolute value of a is greater than 1, or b, the absolute value is greater than 1, the scale change is a stretch in the horizontal or vertical direction. When the absolute value of a is less than 1, or the absolute value of b is less than 1, the scale change is a shrink. Okay? That's important to remember. If it's greater than 1, what happens is, remember we're talking about absolute value, so it's always positive. If it's greater than 1, what we have is a stretch. If it's less than 1, so in between 0 and 1, what we have is a shrink. Okay? Example 1 says, Consider the triangle at the right. Find its image under S of 4, comma, 0.5. Okay? So what this means is we're going to take all our x values and multiply it by 4. Take our y values and multiply them by 0.5. So what happens here is we're stretching our x values, we're stretching them out, and we are shrinking our y values. So let's pick out some points here. Well, A is 0, comma, 2, 4. B is 5, comma, 6. And C is 6, comma, 0. And we're getting A prime, B prime, C prime. So all we're doing is taking the x value and multiplying it by 4. Well, 0 times 4 is 0. 5 times 4 is 20. 6 times 4 is 24. Okay? My y values, I'm taking it times 0.5, so multiplying it by a half. 4 times a half is 2. 6 times a half is 3. 0 times a half is 0. And now if you could plot those points, okay, if I had a little bit bigger graph, and very handily, okay. Moving on. The scale change theorem, okay? This is the matrix you're going to use on your calculator to multiply those points times the scale change. Notice they put the A in the top left, B in the bottom right. Everywhere else is a 0. Remember I said it's just like a size change. The only difference is these two numbers in the diagonals are different numbers. Okay? So quiz yourself says, what is the matrix for S of 7, comma 4? Well, in my top right is my A. What's my A? My A is 7. My B is 4. That goes in the bottom right. This is how easy it is. A, B, A, B, A, B. Zeros everywhere else. Example 2 says, consider the quadrilateral ABC with A equaling negative 2, comma 5, B equaling 0, comma 7, C 4, comma 1, and D a negative 4, comma negative 1. Find its image under S of 3, comma 2. Okay, I'm going to do this by hand. I assume you all can do it on your calculator. Remember, we got to make our size change or scale change first. So this goes 3, 0, 0, 2. And if you remember what I said before, since this is a 2 by 2, and this is going to be a 2 by something, because we got to go x's and y's, this has to go first when you're multiplying them. Because this is going to be a 2 by 4, because that's how many points we have. Okay? So, x's across the top, y's across the bottom. So, negative 2, 5, 0, 7, 4, 1, and negative 4, negative 1. Okay? Here's my A, here's my B, here's my C, here's my D. I just got to make sure I didn't mess up anywhere. Okay, looks good. There's my size change matrix. even easier. And what this scale change, I keep on saying size change, I apologize. What my scale change is saying is I'm taking all my x values and multiplying it by 3 and taking all my y values and multiplying it by 2. Now it's going to do that for you on your calculator, or you can do this by hand very easily. So 3 times a negative 2 is a negative 6. 3 times 0 is 0. 3 times 4 is 12. 3 times a negative 4 is a negative 12. 2 times 5 is 10. 2 times 7 is 14. 2 times 1 is 2. And 2 times a negative 1 is a negative 2. Here is my images, A prime, B prime, C prime, and D prime. Notice that a scale change may or may not stretch or shrink by different factors in the horizontal and vertical directions. If the factors are the same in both directions, then the scale change matrix is in the form of just a size change. Okay? Size changes are special types of scale changes where the values right here are the same. And I think we talked about that before. That's why Mr. Johnson sometimes says size change instead of scale change. So keep in mind a size change is just where this is the same number. Okay? A scale change is where these numbers are different. That's all I have for you today. Please enjoy. We'll see you tomorrow.